These are the topics that are on the final exam coming up that are from Chapter 5 that we were discussing on Friday. It says identify the best, the choice that best completes the statement or answers the question. Name an angle bisector. Well, go to the diagram. Look for an angle that's cut in half by some marks. It has the markings on it. What would it be? Okay, where's an angle that's bisected? Thank you. Bryce? Oh, I thought you raised your hand. You guys, if you can't identify this, you're going to miss some definite questions that aren't that hard on the final. Kenny? Oh, you're saying GL. So, yep, the ray that goes from here to here, that is bisecting that angle, and those marks are what show it to you. So, ray GL. Something that bisects an angle is a ray. All right, next I'm asking to find a median. Okay, let me remind you of what a median is. It goes to a vertex to the midpoint of a side. You want to find a side that's cut in half. Okay, so you find the side cut in half, and then you try to pick the right one because you have a 50-50 chance. Is it? All right, here's the side that's cut in half. Everybody find it? Goes from a vertex to this side. So it has to be HJ. Do we understand why that's the median? Okay. Vertex to the midpoint. Okay, altitude is the tallness. Now, it may not be sitting so that it looks like an altitude. Usually when you measure yourself, you would stand up straight. But somebody could measure you laying down from, but you'd want to be straight though, right? All right, so I'm looking for something with a right angle, but it has to go from a vertex also. So what could that be here? It's either this or this thing, and this thing isn't hitting a vertex, it's going straight through. So it should be KI or IK, and that is choice A. Oh, by the way, on a quiz or test, if there's little blanks next to your numbers, you're supposed to put the answers in those blanks. It really helps the speed of grading if it's multiple choice. Name a perpendicular bisector. Okay, now I need something that makes a right angle and cuts a side in half. It has to do both, and it can pass right through the triangle. What's that going to be? You guys, you're going to have to identify them on the final. I will not be hinting. If you know the vocab, you should be able to figure it out. Perpendicular, right angle, cuts a side in half. So it's got to be whatever that is. And some kids seem to think it's going through H. Is that actually hitting the point H? No. So find two more letters on it. The J and the M. Okay, so it's a line, JM. Okay, now maybe this will help. Draw an altitude. And all I'm going to have you do is sketch these. I don't expect them to be perfection, but I want markings that indicate what you're trying to show me. So if I want to draw an altitude from point Q, you would go straight down to PR, and you just show there's a right angle. That's it. You could literally take an index card and make that segment. Mine's nice and fat to make it look like I did a good job. All right, draw a median from point Q to side PR. A median is in the middle of the road. So you want to find the middle of side PR. So I'm going to go ahead and say that's the middle. And I'm estimating it, so I'm going to show these slashes like I really found it. You could use a ruler and do this. I just want you to have a concept of it, so I'm not asking you to measure and everything else. All right, now, you draw it to where, though? It's got to go to a vertex, and it's said to go from point Q. to the side. So it should connect from Q to the midpoint of the side. Good enough. Number 7 says draw an angle bisector of angle QPR. You need to know where that angle is. QPR. The middle, oh, it says QRP, not QPR. Hello? It says QRP, so I got to figure out that's over here. QRP. The R's in the middle. That tells me where the angle is. It also tells me that the angle is formed by side QR and QPR. Right. I want to draw an angle bisector. So that means I want to cut this angle in half. So we cut it in half. I make the little arc marks showing I meant it to be cut in half. A ray is what cuts an angle in half. That's all I'm asking. Draw something that looks like what I'm trying to get you to show me. Perpendicular bisector of PR. If you're going to bisect PR, you're going to cut it in half. So find the middle of it. Right? So I made a point. It's in the middle. Now I'm going to do it with a perpendicular bisector, which means I need to come straight down at a right angle through there. And it's just a line that cuts through there at a right angle. I hope this is helping you see what these look like. Okay, 10 says draw a median, and it says to do 2 of them. You want a median to side QR, which means it has to come from P to the midpoint of QR. There's one of them. And I know mine's not perfect. It also says to draw a median to the side labeled PQ, which is up here. So that means it has to be halfway between P and Q. I'm going to make a dot. I'll make double slashes there. And then I have to come from R to that spot. Oops, terrible. Oh well. Now I could talk to you about what happens when you draw all 3 of these things. Where they intersect is actually called the center of gravity of the triangle. Okay, put the measures in order from smallest to largest. What measures? Well, it says put the angle measures. And then you look at the picture and you go, well, what the heck? They gave me all the sides. Well, that's because there's a relationship between the length of the sides and the size of the angles. The smallest angle is opposite the smallest side. So angle E is the littlest. The medium-sized side is across from the medium-sized angle. So 10 tells me angle D is in the middle. And the largest side is 14. That means the largest angle is angle F. Okay, so for 11, we would like to know what angle K is. So we're going to do our triangle angle sum theorem, and we're going to do 180 minus 90, which gives me 90 left, and then subtract 32 from that, and we get 58 degrees for angle K. It says to arrange the sides in order from smallest to largest, so I look for the littlest angle. The littlest angle is 32. The side opposite that angle is side JK or KJ, and that is the smallest side. The medium-sized side would be across from the 58, JL. I don't know why my arrows are going past my pictures or my sides, but anyway. The biggest of all angles is 90, so the biggest of all sides is across from it, KL. And the hypotenuse is always the biggest side in a right triangle anyway. Okay, anybody still need this before I flip? I know nobody can answer if they're watching the video, but all right. This is not as important as the ones we just went over. However, I would like to tell you that the angle bisector is equidistant from the sides of the triangle. This triangle would also be the same size as this triangle below. So if you wanted to know angle TQR, it would have to be the same as SQR, so it would be 43 degrees. This next one, number 13, these two segments are equidistant from the angle bisector, so they're the same length. So 5x minus 7 equals 3x plus 5. That's the setup. To solve it, you're used to doing this. Subtract 3x. 2x minus 7 is 5. Add 7. 2 times x is 12, and then divide, and we get x is 6. But it didn't just ask for x. It asked for x to z. Segment xz would be 3 times 6 plus 5, which is 18 plus 5, and that's 23. Okay. All right. I'd like some more help with this, please. Oh, my. 23. Name the special segment in each. What is this? A what? Okay, it is a perpendicular bisector. Did anybody think something else? A what? Median? It is also a median. Could somebody name it another thing? It's an altitude, isn't it? This is a weird one. I honestly would have to take any of those solutions because this is a special triangle, and that segment is both a perpendicular bisector and median and an altitude. Now, I will be much more specific on the final. I would not trick you like that, okay? But 24, I hope you can tell, what's this thing out here? That's an altitude. And then what is this segment in 25? It just goes from a vertex to the midpoint of a side. So median, I heard. And then this would have to be an angle bisector. Oh, I forgot the C. There it goes, angle bisector. Got some fill in the blank here. The sum of two sides of a triangle. Oh, what happened when you add the two sides of a triangle? What are you supposed to get? Something greater than what? The third side, okay? If two sides of a triangle measure 10 and 15, then the third side must be greater than what and less than what? Meaning, what does it need to be between? Do you remember how we figured that out? Say that again. 15 minus 10 and 15 plus 10. Yep, so that's 5 inches and 25 inches. So it's got to be between those dimensions. It can't equal them. It has to be between. The longer side of a triangle is opposite the what angle? Across from what angle? Largest, yes. And likewise, the shortest side of a triangle is opposite the smallest angle. Angles don't have length, so we can't say shortest. That was cute. We did not do 31 and 32, so you can cross that out. We didn't talk about the special points of concurrency this year. I've done it before, but not today. Now, which of the following side lengths form a triangle? You want to take and add the smaller two. Is 5 plus 6 greater than 12? That's what you're checking. No, it's not. Okay. Is 2 plus 5 greater than 9? No, it's not equal. Not greater. 8 plus 2, is that bigger than 8? Yes, this is a good one. So C is good, and then 9 plus 10. Oh, I didn't, yeah. It's greater than 15, so this one's another yes. It just said circle all that apply. So there were 2 answers that were good. Okay, now describe the possible lengths of the third side. That's when you add and subtract to get the range. 21 minus 16 and 21 plus 16 tells you that it needs to be between 5 and 37. You can write it like this as an inequality. That's how you're usually going to see it. X is between 5 and 37 is what that says. Or if I didn't have that as the option, you might say between 5 and 37. So this is going to be between 2 and 46. Everybody get what I did? 24 minus 22 and 24 plus 22. How are you doing so far? Anybody need anything or have a question before I go on? All right, let's see if we can identify these points of concurrency. Actually, we're just doing naming the median, and mode. Or not, no, hello. Median, altitude, perpendicular bisector, or angle bisector. All right, I'd like to note these statements up here. And I would like to be able to mark some things on the picture based on those statements up there. AF is congruent to FC would mean that F is a midpoint. BH congruent to HC would mean H is a midpoint. An angle ABE up here congruent to angle EBC over here, that helps with angle bisector. So we're asked to find a median first. Can someone look at the diagram and see if you can figure out which one is a median? It should go to one of the midpoints. It should also connect to a vertex, which is A, B, or C. The only one that's connecting to anything is B, so it's going to be something with B in it. Okay, I'm seeing some hands. All right, Robert? BF, yep, that would be a median. And that's choice B. Okay, number 2 says an altitude of the triangle ABC. I need a right angle, and I need to come straight down or up from a vertex. Bryce? BC? BD. Good. Yep, segment BD. Okay, then I need a perpendicular bisector. Now I can go spline through the whole triangle. The line. Oh, well, that gave it away. I need a right angle, Cadence. FG or GF, yep, it's this thing, because it hits at a right angle and it hits at a midpoint. And we already identified F as a midpoint. Or line, it was A. Okay, and then an angle bisector. Oh my gosh, guys, we're going to have to go up here and look at this. So as angle ABE was congruent to angle EBC. So what's the ray cutting that in half would be? BE. And then last, a mid-segment, it's when it hits 2 midpoints. So that would be that thing right there, which is FH. Okay, now you're going to work and then turn it in and grab a review after you're done and you give it to me. Finals are coming.